All right. So before we talk about what an inverse matrix is, we need to know what the identity matrix is. Okay? So an identity matrix is a square matrix that consists of ones across the main diagonal and zeros everywhere else. Isn't it? Okay, so an identity matrix is square, ones across the diagonals, and zeros everywhere else. So this is the 3 by 3 identity. Okay, the 2 by 2 identity matrix would be 1, 0, 0, 1. Right? As long as it's square, we can write an identity matrix. Okay, now let's think back to some properties. If we're talking about numbers, like multiplying numbers, what is the multiplicative identity? Think back to you. We talked about this in algebra 2, I believe. For sure, geometry, when you did proofs. Multiplicative identity.
Isn't that is it going to be like the reverse over, like a times b equals b?
That would be the commutative property. Okay, but you're on the right track. Multiplicative identity is 1. Why is the multiplicative identity 1? Yes. So here is our matrix identity. What's going to happen when we take a matrix times this identity? It's going to be itself. Okay? So I stands for identity. If I take the identity matrix times A, we're going to get A. We take A times the identity, we're going to get A. Okay? Obviously, A has to be also square, right? But we're going to use that to help us here in a little bit. Now, when we first introduced matrices, we talked about a square matrix and how it's going to be special. Okay, first of all, a square matrix is special because we have an identity matrix. The second way that a square matrix is special is that we can find, sometimes we can find an inverse matrix of a square matrix. Okay, so let's talk about what an inverse is in numbers. If we're multiplying, here's our multiplicative identity. What's our inverse property? It's 1 over A times A. And what is that? 1. They kind of cancel each other out, right? So we want to do this with matrices. Okay. So first of all, our matrix, our inverse matrix, we're gonna notate as A inverse, much like we would with like F inverse, right? So A inverse is going to be our inverse matrix. Okay. Like I said, this can only happen if we have a square matrix. Okay. So if an inverse exists, then A times A inverse is the identity, or A inverse times A is the identity. Okay, kind of like multiplication. If we take 2 times 1/2, we get 1, or 1/3 times 3, we get 1. Okay, that's what's happening with our inverses. If we have a matrix and its inverse. We multiply and get the identity. Okay. Couple notes. A non-square matrix cannot have an inverse, and not all matrices have inverses. Not all square matrices. There are going to be times where an inverse doesn't exist. So a matrix is very special if it has an inverse. First of all, it's square. Second of all, not all square matrices have inverses. So it's pretty special if it does have one. So let's think about what it means to be an inverse, okay? Right here, we want to find the inverse of this matrix. Go ahead and write it down. If an inverse exists, when we take this times the inverse, what do we get? The identity. Thank you. So if we take this matrix times, I'm going to say that A, B, C, D, this matrix is A inverse. Then we'll get the identity, right? Are you with me? Okay. So, here we go. If I multiply these two together, what do we get as our first entry?
1A.
1A plus 4C. What about first row, second column? What about second row, first column? Minus 3C. And then second row, negative B minus 3D. And we know that has to equal 1, 0, 0, 1. Okay. What do we know about A plus 4C? It has to equal 1. Right? We have equality of matrices. You don't like it? Yes.
I'm not understanding like A plus 4C.
We're multiplying row times column. 1 times A plus 4 times C.
Okay.
Yeah? Okay. What do we know about negative A minus 3C? Has to equal 0. What do we know about B plus 4D? That has to equal 0. And what do we know about negative B minus 3D? It has to equal 1. So what do we have? What do we have? We have systems, right? If we add these two together, we get C equals 1, which would make A what? If we add these together, we get D equals 1, which means B equals negative 4. So, what have we found with this? we have found that A inverse is -3, -4, 1, 1. Okay. That's a little bit of work, isn't it?
Yeah,
Some of you are a little frustrated, weren't you?
too much work.
Too much work. Okay. What if I told you that there was a pattern in all of this?
Is it like it's called calculator?
Almost. These were almost the same numbers as the original matrix, right? Well, they're kind of switching. Some of them are opposites, right? Okay. So there's actually a pattern to all of this. Would you like to know the pattern?
Yes.
Yes, please. Okay. To find an inverse, this is what we're going to do. If A is A, B, C, D, then our inverse. Okay, how about you just go ahead and write it down, and I'll tell you where the numbers come from. And I'll tell you kind of a way that I like to remember it. Okay, write down all of the letters. I guess they're not numbers right now. Okay, so first we're going to have a scalar multiple on the outside. 1 over AD minus BC. What I like to remember it as is, okay, so AD is here, BC is here. So I like to remember it as like a crisscross, criss minus cross. That's how I like to remember it. Okay? If you don't like that, that's fine, I don't care. Okay? Then those where those letters are and the signs of some of the letters are different. So what happens is across this diagonal, we switch those two numbers, right? And what happens across along this diagonal?
Multiplied by negative.
Okay, they become opposites. All right? So we switch this diagonal and negate this diagonal. Let's practice. Okay, so write down 3, -1, -2, 2. And we're going to find the inverse. Okay. To find the inverse, 1 over, well, let's one step at a time, sir.
Sorry, I just.
3 times 2 minus -2 times -1 times. What do we do with those numbers? So switch 2 and 3 and negate the other diagonal. So we switched 3 and 2 and then we negated -2 and -1. So now we have 1/4 times 2, 1, 2, 3. So our inverse matrix is 1/4 times 2, 1/4 times 1, 1/4 times 2, and 1/4 times 3.
That's about it.
Let's try another one. Okay, so our inverse, we're going to take 1 over 6 minus 7.
Are you fine?
Okay. One over 0. Can we divide by 0? No. So what happens is that the inverse doesn't exist. Remember how I told you that not all square matrices have inverses? Okay, so this is what's happening. When we go to find the inverse, we're dividing by 0, and that's not okay. So the inverse doesn't exist. We can't do it. Okay, you like those? Get out your calculator. Now, there is not a really nice way to do a 3 by 3 inverse by hand. Okay, we're not going to do it. So anytime you are asked to do anything with a 3 by 3 inverse, you are going to do it by hand or with your calculator. Okay. Anytime you have to do anything with a 3 by 3 inverse, you're going to do it with your calculator. So here is what we're going to do. If I can find my calculator and make it smaller and bring it over here. Okay. So the first thing we need to do is enter our matrix into our calculator. So everyone go to your matrix. And we're going to edit. I really don't care which one it is, but I like to go to A because it's easy to pull up. What's the order of that matrix I have up there? 3 by 3. Are you laughing at me? It is okay to sing, especially if it's about math. Yeah, it's a company that does it every year. They travel around and that's what they do. Okay. If you know calculus.
Where do they come with an idea of that? Wow.
Somebody who has a passion for math and a passion for music, they combined those two passions and made a wonderful production.
They're like wake up in the morning and they're like, oh, I think we'll make a musical about calculus.
And it's pretty popular. They've made some money doing it. So
There it is.
okay. All right, so now what we're going to do, we want to find the inverse. Okay, so we need to call up our matrix. So please call up A. And you see how you have this like x to the -1 button? That means inverse.
Oh.
That was nice.
Everyone finding it all right?
Just do to the negative.
Do you know how to get you entering in?
What? Still negative. Like, just do the carrot from the -1.
Oh, that's a more advanced calculus. Yes. It comes with a lot more functions.
That would be good.
Because the PI-89 is banned on the
I know you have that button somewhere. Okay. So now, what is the point of doing this? Okay? There's got to be something that inverse matrices can be useful for, right?
Okay, to help us find reduced row and echelon.
inverse matrices can help us solve a system of equations. Write the system down.
Just when we think we're done with these.
Do not write this in a matrix. Write this. It just has a system of equations, okay? Now, we know how to write this as an augmented matrix to solve the system. Now what we're going to do is we're going to write it as a matrix equation.
Oh boy.
All right? So, we can write this as the coefficient matrix times the variable matrix equals the constant matrix.
That's a lot of boxes.
Okay, it's a multiplication of two matrices that equals another. Watch. Row times column. 18 times x plus 12 times y equals 13. Right? Row times column. 30 times x plus 24 times y.
So why can't you just like write it as 8 times 12 y? Like just, because you already know because there's multiple.
Right. So instead of multiplying these two, okay, because then we're just using algebra. I want to use matrices. Okay? So let's talk about this. Okay? Here I have matrix X times A, matrix A, times, I'm going to call this matrix X equals matrix B. And I want to solve for this matrix right here, right? That's going to be our goal, so we know X and Y. Okay, do we know how to divide by a matrix? Well, we know how to multiply by the inverse. So if I want to solve for this X matrix right here, we're not going to divide by A, we're going to multiply by the inverse of A. Now, please pay attention. Since we have to multiply the inverse to the left of A on this left side, A inverse needs to go on the left of B over here.
Is B the 1320?
B is this right here. Yes.
So when we multiply the inverse of the original matrix, will they cancel out?
They do. They cancel out to be the identity, right? And anything times the identity is itself. So, once we do this, our variable matrix will be by itself. Okay? So, let's find this inverse, shall we? So, what is A inverse? I'm going to need your help here. 1 over Chris minus Cross.
432. $72.
72 is what Kyler is telling me. 1 over 72. And then we're going to switch 18 and 24. Okay. And we are going to negate 12 and 30. Okay. So A inverse is going to be 24 70-seconds, negative 12 70-seconds, negative 30 70-seconds, and 18. Oh, we can reduce those, can't we?
Yes. Oh no.
Help me out. What are those reduced to?
1/3.
I can give you the decimal.
1/3. Negative. Negative and,
You can reduce that even more.
okay. 5/12 and 18/72. Okay. So 2, it's just 1/4. Okay. So now, to get x, y, we decided that we need to take A inverse times B. So A inverse is this. Times B.
A lot of steps.
Okay. So let's multiply. Row times column, we have 1/3 times 13 plus negative 1/6 times 23. And then we have row times column, negative 5/12 times 13 1/2 and 1/3. Okay, now, the ones that I give you on your homework, the numbers will be much smaller. Will that work? Okay, let's practice with your calculator. Okay, I'm going to give you this system right here. Okay, anytime you get a 3-variable system and I ask you to solve using an inverse, I want you to use a calculator. Okay, we don't know how to find a 3x3 inverse, so we have to use our calculator. So first of all, let's set up our matrix equation. We would have 2, 3, 1. 3, 3, 1, 2, 4, 1. Those are the coefficients, x, y, z, times our variable matrix equals negative 1, 1, negative 2. So if we call this A, X equals B, if we name those matrices A and B, how do we get X by itself? Okay, since A inverse has to go on the left of A inverse has to go on the left of B. Okay, So this is what I would do. Go to your calculator. Where's my calculator? And we're going to make A our 3 by 3 matrix. So A is going to be 2, 3, 1, 3, 3, 1, 2, 4, 1. Then we can enter in a B. If we go and edit B, what's the order of B?
3, 1.
3 by 1. Oh, and I covered up P. Is it 1, 1, negative 1, 1, 2?
-1, 1, -2.
Okay. So Kyler, how do we enter this into our calculator?
Well, I just press the multiply button, keep the inverse, kill, carry it into it. And then multiply by B.
But that's not the right A inverse
Why?
because we changed A.
To what? It's not the inverse yet.
That's the old problem.
Oh.
Okay.
I thought
We're on the same page now. Okay. So we need to call up A.
Yep.
Inverse. And multiply it by B. Pretty sweet, right?
I got 1 6 make it 1, 2.
Okay, so if you're not getting the same thing as me, you probably typed an entry incorrect. It can just be one number. Okay. Okay, so your homework is this. Anything that is a 2 by 2, you must do by hand. Anything that's a 3 by 3, you must do with a calculator. You're glad I'm telling you you have to. And we have 10 minutes, so you can get started.